Senapati, and I am here to present four problems on machining time calculation. This is the first problem, which is end mill cutting. The question is to determine the cutting time in cutting a 130 mm long keyway using HSS end mill of 20 mm diameter, having 5 cutting teeth, and depth of keyway is to be 4.5 mm. The feed of tooth is 0.15 mm and the cutting speed is 95 meter per minute. This is the respective diagram. This is the length of keyway to be slotted, and this is the diameter of the end mill cutter. Here the given, take the length is equals to 130 mm and diameter equal to 20 mm. Number of cutting teeth is 5. The depth is equals to 4.5 mm. Here the feed per tooth is 0.15 mm. The cutting speed is 95 meter per minute. Here solution. We know the formula for RPM equal to V into 1000 divided by pi into D. Here N is the spindle speed, V is the cutting speed, and D is the diameter of the tool. Is substituting V equal to 95 meter per minute into 1000 divided by pi into 20 mm diameter. After we calculating is 95 into 1000 divided by pi into we get 1511.97 RPM. And we have to calculate feed per minute, that is feed rate FR, which is equal to feed per T into number of cutting teeth into RPM, which is spindle speed. Here the feed per cutting teeth is equal to 0.15 into number of cutting teeth is 5, and the calculated spindle speed is 1511.97 RPM. Here the feed rate is 0.15 into 5 into 1511.97, 1133.97 mm per minute is the feed rate FR. And we have to calculate the length of cutting, which is equal to length of workpiece plus length of approach. We know that the length of approach for this end mill process is half the diameter, which is D by 2. The length of workpiece is given 130 mm plus we know the tool diameter is 20 mm. Here the length of approach is 20 by 2, which is 10 mm. We are adding 10 mm, and the total length is 140 mm. And the machining time is equals to, we know the formula, length, that is total length divided by feed rate. Here the total length is 140 mm and the calculated feed rate is 1133.97 mm per minute. After calculating, we get the machining time equal to 0.12346 minutes, which we have to convert into seconds, which is we should multiply this value into 60, which is 7.4 seconds. Machining time is approximately 7.5 seconds. The sum is based on the drilling process. The question is to calculate the time required to make the holes as shown in the figure, considering a spindle speed of 2000 rpm. In this, given is n equal to 2000 rpm and a feed rate of 0.01 mm per revolution. Feed rate equal to 0.01 mm per revolution. We have to take the drill approach length as 2 mm and over travel length as 3 mm. We should ignore the time required for drill to withdraw from the hole as well as for moving drill from one location to another location. From the given diagram, we take the number of holes is here 4 plus 2 plus 4, which is n equal to 10. Number of holes is 10 and the drill depth is 15 mm from the diagram. We know the formula for machining time is length of drill into number of drill divided by spindle speed multiplied by feed rate. Here length of drill is equals to depth approach plus over time. Here depth is 15 mm, given approach is 2 mm and given over time is 3 mm, 20 mm. After substituting, we get 20 mm length of drill. Drill is 10, which 10 and the spindle speed given is 1000 rpm into the feed given is 0.01 mm per revolution. After calculating, we get 20 into 10 divided by 2000 into 0.01, which is 10 minutes. This is the machining time required to machine the 10 holes. Third sum, here we have to determine the machining time needed to produce the component depicted in the figure with a spindle speed of 3200 rpm, which is n equal to 3200 rpm and a feed rate of 0.1 mm per revolution. Feed rate is 0.1 mm per revolution and a depth of cut of 2 mm per pass, and the tool non-cutting time, which is here the non-cutting time is 2 seconds. Non-cutting equal to 2 seconds per pass. In this diagram, we can say the initial diameter is 50 mm. From the initial diameter of 50 mm, we have to machine a step turning of 30 mm, which is the final diameter equal to 30 mm. And the length of turning is 30 mm. And we can go for the solution. We know the number of passes formula is initial diameter minus final diameter by 2 times of depth of cut. Here initial diameter is 50 mm minus final diameter is 30 mm divided by 2 times of depth of cut is 2 mm. After calculating we get 20 by 4, which is 5 passes. For this step training operation we get 5 we require 5 passes to do the step turning. And we know the machining time formula, which is length of machining into number of passes divided by feed rate into spindle speed. You know the length is 30 mm, the number of passes 5, and the feed rate is 0.1, and the spindle speed is 3200 rpm. Which is 0.4687 minutes. We convert into seconds by multiplying 60, we get 28.125 seconds. We have to add non-cutting time, which is 2 seconds per pass. Total non-cutting time is number of pass into non-cutting time for single pass, which is 5 into 2. Totally 10 seconds is a non-cutting time. The total machining time is 38.125 seconds, which is approximately 38 seconds. For this turning operation we require 38 seconds of machining time to complete this process. Fourth problem. In this the question is a block of length 200 mm is machined by using a slab milling cutter of 34 mm diameter. Depth of cut the table feed are set at 2 mm and 8 mm per respectively. Considering the approach and over travel of cutter to be same, find the machining time per pass in minutes. And this the given is length is equals to 200 mm and the depth of cut is 2 mm. Table feed rate is 18 mm per minute. And for this the approach is formula we get approach or overtime is equals to root over d into capital D minus small d. In this d is the depth of cut, capital D is the diameter of the cutter. Capital D is the diameter of cutter, which is 34 mm. After substituting we get the approach or overtime equal to root over 2 into 34 minus 2, which is root over 2 into 34 minus 2. Approach or overtime equal to 8 mm. And the machining time per pass equal to, we know the formula, length plus approach plus overtime, over travel, divided by feed rate. Here the machining time is length is 200 mm plus Here the path of approach and over travel is same, so we multiply 2 into 8 divided by 18 mm per minute, which is 200 plus 2 times of 8 divided by 18, which is 12 minutes. For this machining operation, we require 12 minutes of machining time to complete this slab milling process.